Alright, so this video is going to be for doing the table FRQs. And so on these table FRQs, only selected values of the function are given. And so you're going to be asked to, maybe both, to either or both approximate or interpret the derivative and or an integral. And so to approximate a derivative, you're going to use the average rate of change. And to approximate an integral, you're going to do a Riemann or trapezoidal sum. And it will tell you what to do. So it'll either tell you a right or left Riemann sum or midpoint, or it'll tell you a trapezoidal sum. So you don't have to decide, just do what it says. All right, and then you're likely going to have to use a theorem. And so the theorems that you would use on these tables are going to be either the intermediate value theorem, or the mean value theorem. All right, and so let me pull up. We're going to do number 4 on 2018 as our notes. All right, so on number 4, the height of a tree is given by a twice differentiable function h, where h of x is measured in meters and t is measured in years. Selected values of h of x are given in the table. All right, A asks us to use the data from the table to estimate h prime of 6 and using correct units or interpret the meaning of it in the context of the problem. And so to evaluate a derivative, we are going to find the average rate of change, and inside of the t values that we use, 6 has to fall. And so the best one to use is the interval closest to 6. Now, I do think other intervals will give you your points, but it's good practice just to do the best interval. All right, so open up to number 4 for 2018, and we're going to do all those things. So we're going to start off by finding the average rate of change. Now, you need to tell the reader that this is what you're finding. H prime of 6 is approximately h of 7 minus h of 5 over 7 minus 5. Right? And then looking at your table, that's going to end up being 11 minus 6 over 2, or 5 halves. Okay. And then don't forget, that is telling us to interpret the meaning of this. And so we would say something like h prime of 6 equals 5 halves means, now don't forget, when we do an interpretation, we do the nut. So the noun is the height of the tree. So we're going to say on average, because it's the average rate of change, the height of the tree, and then we have to say if this height is increasing or decreasing. Since it's a positive rate of change, we're going to say increasing. 5 halves. And then we need to do a unit. And so it started off as meters, and then the independent variable was time in years, and so it's going to be meters per year. And then we need to do a time which is at t equals 6 years. So don't forget, when you do a derivative, your units, you take the dependent unit, which is meters, and divide by the independent unit, which is years. All right, and then for letter B, we want to explain why there must be at least one time t for t between 0 and 2, such that the h prime of t equals 2. This is the mean value theorem. We're saying that there must be one time where the average rate of change is equal to the instantaneous rate of change. So we want to find pairs of numbers here that whenever we do their average rate of change, that we get 2. Now, it would have been really nice if we got 2 for part A, but we didn't. So you just need to take a second and look and see if you can do a pair of numbers to get an average rate of change of 2. And those pairs of numbers are going to be from 3 to 5. So when you subtract, you're going to get 4 over 2, which is going to be 2. All right, so what you would say is that h of 5 minus h of 3 over 5 minus 3 equals 6 minus 2 over 2, or 2. So if we can find an average rate of change that equals that derivative we want, then we can use the mean value theorem as long as the function h is continuous on the open interval and differentiable on the closed interval. So what it tells us in the beginning, the very first sentence, is that h is twice differentiable, so that's going to cover everything. So let's just make a note of that. You do need to talk about the conditions when you use the mean value theorem. All right, so h of t is twice differentiable. Thus, continuous on, and then it only needs to be continuous on the open interval for these x values, and it needs to be differentiable on the closed interval. All right, so we've done all the work. Now we just need to write the mean value statement. So we are going to write out the whole word. We're not going to call it the MVT on the AP exam. So by the mean value theorem, now it's an existence theorem, so we're going to say there exists, and then I'm going to go back and kind of quote the problem. So we're trying to say there must be at least one time, so I'm going to say there exists a time t Now I'm going to use the interval we have here, and then in the end we'll get it all straightened out. We know that there's a time between 3 and 5 such that h prime of t equals 2. And then I would do something like this interval is inside the interval that they were asking us to find. All right, and then part C, we're going to use a trapezoidal sum with 4 intervals indicated by the data in the table to approximate the average height of the tree over the interval from 2 to 10. And so on part C, I would take a second and I would say what we're going to do to represent the average height. So the average height over 2 is less than or equal to t is less than or equal to 10 is given by, and then the average value formula, remember we have that fraction in front of the integral that uses the interval from 2 to 10. Okay, and then I would go ahead and use the trapezoidal sum to approximate that integral. Okay, so don't forget that 1/8. All right, and so what we're going to do, so we're going to have four trapezoids, and so for trapezoids, you add the bases, divide by 2, and multiply by the heights. All right, so this is kind of hard for me to do flipping back and forth, but you can look at your paper. And so for the first trapezoid, we're adding 1.5 and 2 and dividing by 2. And then we're going to multiply it by the height, and the height is basically the width, the distance between 2 and 3. And the distance between 2 and 3 is 1. All right, the next trapezoid, we're going to add 2 and 6. And then multiply by the distance between 3 and 5, which is 2. All right, and then the next one, we're going to add 6 and 11, and the distance between those is going to be 2, and then 11 and 15, and then that distance is 3. All right, and then when I write my statement, I'm not going to go down to just a final number, but I am going to, I can add these together faster than I can just rewrite it again. And I can cancel those 2's out faster than I can write them again. So it's about getting it right, and it's about not running out of time also. So I would say something like the average height, and we're just quoting the problem, is, and then 1/8 times, and then I would do 3.5 over 2 plus, and then I would go ahead and add these and cancel these, and so that would be plus 8. And then same thing on this one, I would add these and cancel these, so that would be plus 17. And then on this last one, I would go ahead and add, but nothing cancels, and I would just leave it like that. But I do want to give units, and so the average height units is going to match the height units, so that's going to be meters. Over the time interval. Is less than or equal to t is less than or equal to 10. Now, if you're totally running out of time, it probably would be okay if you just put meters up here and hoped and prayed you did enough. But we want to not run out of time and get to every question. So this last one is probably going to take the most time. And so it says that we're actually not going to use the table on this one at all. So the height of the tree in meters can also be modeled by the function g, where x is the diameter of the base of the tree in meters. When the tree is 50 meters tall, the diameter of the base of the tree is increasing at a rate of 0.3 meters per year. According to this model, what is the rate of change of the height of the tree with respect to time in meters per year? And at the time, when the tree is 2 meters tall. Okay, so this is a related rates question, and there's a good chance they're going to throw one in on one of the parts. So it's good to practice this. So looking at your paper, we're going to write what we're given. And so we're given that the diameter, which is going to be x, is changing or increasing at 0.03 meters per year when g of x is equal to 50 meters. we want to find dg dt, so how fast or the rate of change of the height of the tree is dg dt when g is 50 meters. Okay, and so to find dg dt, I'm going to take g, which is this function, and find its derivative with respect to time. And so to find that derivative, we're going to do the quotient rule. So it's going to be low d high minus high, minus high d low over low squared. And then because I was finding the derivative with respect to time, I have to do a dx dt. All right, now I'm going to take a second. I'm going to clean this up a little bit. So I'll distribute the 100. I wouldn't square that. I would just leave it like that. All right, and then finally I can do 100x minus 100x. All right, and then I hope you guys remember the magic moment. So the magic moment is when g is equal to 50. But the thing is, we don't have anywhere to plug in g. We have to plug in x. And so what we need to find is what the x is when g is 50. And so I would put 50 in for g, and this is into the original problem. And I would solve it for x. So x is equal to 1 at the magic moment. And so I'm ready to plug everything in and find dg over dt. So I am going to put 1 in for x. And I'm going to put 0.3 in for dx dt. Okay, and then when I multiply 100 by 0.03, that decimal gets moved 2 places over, and that's just going to be 3. And then 1 plus 1 is 2, and 2 squared is 4. And then you would want to give I think it tells you in the problem what the units are, but I would also go ahead and give the units. Yeah, it tells you in meters per year, but that's okay. I would go ahead and give them. All right, so that's a related rates question, and then all of that is a possible table FRQ that you might see.